Hey, how's it going, guys? It's Guillermo Mata from Cs490, and today I wanted to show you guys how to make visual animations using parametric equations and processing. So by the end of this tutorial, I'm gonna show you guys how to make an effect similar to this. And really what inspired me to make an effect like this, there's a lot of techno artists as of recently that post really minimalistic black and white simple animations, and I wanted to try to recreate that. However, I wanted to add my own twist and kind of like make a simplified black and white version of like a Windows 98 retro screensaver. So luckily through searching the internet, I found out these type of repeatable animations are actually easily created using parametric equations. So that's what we'll be talking about today. Before we get into anything though, I want to introduce processing in case you guys are unfamiliar with the processing software. Processing is an open source IDE built for the visual arts communities with the purpose of teaching non-programmers the fundamentals of computer programming and visual arts. Processing is really simple. It essentially just uses a simplified version of Java, so it's really easy for programmers of all skill levels to adopt it. And yeah, so once you download the program, it might look a little bit like this. To start off with, I just want to briefly talk about parametric equations in case you guys don't remember what they are. Now, I'm assuming as computer science students, you guys recall the most popular form of a line, which is slope-intercept form, might look a little bit like this. I assume you guys would also know how to plot the equation on the coordinate plane, given an equation like this. Given an equation like this, you would understand we would first go about plugging in values for our variable x and would be thus given our outputs for variable y. Now using these values for our x and y variables, we would now be able to use those pairs to plot the points on the graph. Well, parametric equations are very similar, except we now have a pair of equations instead of a single equation, and we introduce a third variable instead of just x and y. So a parametric equation might look something like this. We might have an equation for our x, and we might have an equation for our y. Now to plot this on the graph, we would instead plug in values for t rather than x, and we would thus be given values for both our x and y variables. We would then plot x and y on the plane, and this would allow us to generate different and more complex curves. So now, how would we go about implementing this in code? First, we would need to write our parametric equations and processing using methods. So how might these methods look? Well, we would want our methods to return float values, so we would name them accordingly. Why is it caps? Why is it caps? There we go. Float x, float t. For now, we'll just have it return 0 as a placeholder because we're not sure what we want it to return yet. And we would want two methods, one for each parametric equation. So go ahead and copy this. We'll have one for our x and one for our y. However, we wouldn't be able to see them just yet in processing with just these two methods, so we'd have to set it up in processing's terms. We would need a setup method, so void setup. And this would essentially create a setup method for the background. Just specify what we want our background to look like. So background 20 would make our background a dark gray color, and size 5 would just specify the size of our sketch. Now that we have the background, we would want it to draw our graph, so we'd have a draw method. Specify some, stroke 255. Then we'd have stroke weight so that we can actually see the dot will be drawing. Now translate will just translate the point that we want to be drawn to the center of our sketch. So width divided by height, height divided by 2. And this point function call will just, draw the point that we specify with the parameters we'll be passing it. So point draws a single point at the specified location. Essentially what we're doing here is we're sending 0 for t to both our methods x and y and plotting the corresponding point of the pair of return values. We're missing a semicolon. Oh, that's a semicolon. That's a colon, not a semicolon. Wait, what happened to our translate? Oh no. Translate width divided by 2. Height divided by 2. There we go. And now you see our dot is at the center of our screen. So this is just one point. How would we go about plotting more points? We would have to go ahead and declare t at the top, float t. And we would alter some of our previous code to now use t as a parameter. So instead of just 0 here, we would pass it t. We would make sure to increment t every frame. And we would return t. Now, depending on whether you make t positive or negative, you'll get different types of lines. We'll keep them positive for now. We could also introduce more complex curves using trigonometric functions, which is what I'll predominantly be focusing on in this tutorial. For example, if we use sine t divided by 10 times 100, you might get something that looks something along the lines of this. Now, if it's been a while since you last messed around with trig functions or sine waves, here's a couple of tips. Multiplying the t, or your variable, increases the frequency, and dividing decreases the frequency. So if we were to multiply it, we'd get something that looks a little bit crazier. Let's do this. Boom. So not really a sine wave you might be familiar with, but it is a sine wave nonetheless. But for the purpose of this tutorial, we'll just keep it divided. And the outside coefficient is actually, or the outside constant is actually going to be responsible for the amplitude. So if we make it lower, it might give us a smaller sine wave. We'll keep it at 100 for now. Now, we can create even more complex animations by using trig functions for both methods. If we wanted to do this, just copy and paste this up here. We'll have a repeating line that just goes back and forth. You can see it's getting darker over time. If we do cosine, you guys might know what happens, but it creates a circle, which is pretty cool. Now, if we want to make things even more interesting, we can go ahead and layer trigonometric functions by adding them together. If we do this, then add this. Boom. Let's just change the value for this. Oops. We might get something more interesting like that. So you can just edit a lot of these values and create different shapes. It's pretty cool. Just, you don't really need to have a perfect idea of what you're doing. You could just mess around, stumble upon something. So, 10. So that pretty much summarizes our intro into parametric equations. Now I'll get into creating our desired effect. To do this, we'll need multiple sets of parametric equations. To start off with, I'll just do 2 different sets of parametric equations. So let's go ahead and just copy and paste this. And we'll make this y2, x2, y1, x1. And now instead of drawing points, we want to go ahead and draw lines to connect these 2 points. So to do so, we'll go ahead and just delete our point call and instead add a line call. So it might look something like this. x1 t, y1 t, x2 t, and y2 t. There we go. Let's see what we get now. Still lines, or still dots. Let's try to make this different. Now you see we have lines. That do be kind of crazy though. Let's see. Let's try to make something different. We've just made this a cosine. Make that a cosine. Alright, that'll do for now. Screw it. Okay, we don't really like this slick. We don't like the lines to stack on top of each other. So to do that, we'll just go ahead and refresh our background every time we update. So background set to gray. And now you see we just have a line just going crazy. However, we did kind of like the trailing effect, so we'll keep the trailing effect to some degree. To do that, we just add a for loop right here. Oh no. For loop int I equals, oh. This constant can be whatever you want. It's just going to be the number of lines you have. I'll go ahead and choose 10. I plus plus, boom. And go ahead and just indent this for legibility. Now we might have, oh no. Oh, we forgot of something. Do t plus I right here. T plus I right here. Let's just go ahead and copy this. And we might get something like this. So that's pretty cool. We can change the speed of our animation by just doing or changing how much we increment our t by. So if we want this at half speed, we do t equals . However, we didn't just want a single line, so I'm going to go ahead and introduce another set of parametric equations in order for me to get a more of a triangular shape. So let's close this for now. Go ahead and go back here. We'll copy and paste this again. rename this flow x3, flow y3. And over here we would have to add an additional 2 lines. Let's see. So we do x2 t plus I. Actually, we could just copy and paste this. Oops. So this would combine our second point to our third point, and we would want our third point to combine or connect, my bad, to our first point. And doing that, we'd get unexpected float. Huh. See, and open up our last one. We already did this before. Let's compare code. Oh, forgot a curly brace. We are still not getting our desired effect. Maybe if we do. And now we get a triangular shape. Oh my god, that was so difficult. But now we see what it might look like. So this is essentially my desired effect. We could go ahead and place some music over it and see how it would look. Let's see. Turn that down a little bit, and boom. That's what it would look like. Seems pretty cool. The one I did earlier looks a little bit cooler with the music. We could go ahead and we'll save this for now. Open up the other one. Let's see, processing. There you go. That's basically it for the tutorial. If you guys enjoyed it, you guys could go ahead and try this yourselves. It's not that hard. Yeah, if you guys have any questions, feel free to just drop a comment in the YouTube section, or feel free to email me at memo.mata13@gmail.com. Thanks for watching the video. Enjoy the rest of your days, guys.